Good day, everyone. Hope you're doing all right wherever you are, and thank you once again for your support on this channel. It really makes a huge difference. Today we've got this big inverter here. It's a Deye inverter. This is one. It's a 8 kilowatt inverter. So it's SG01LP1-EU. So this one, it's a 8,000 watts inverter. It's one of the strong inverters on the market, but today it has got the fault. All these things, they fail at sometimes. So what is the fault? It's the short on the DC bus. So when you connect the multimeter and measure the resistance on the, I'm sorry, not the DC bus, but the battery terminals. Let's put the meter on the ohms. You will see what I mean. See, when you connect plus and minus, there we have a short circuit. You see 1.6 ohm. So this resistance is not good. It's very low. So what's happening is there's a MOSFET and driver circuit underneath. I'm gonna take it out so you can see. I've already took out the Allen keys there. Okay, so when you open the inverter, you can see there's lots of boards there inside here. So this one is a control board. Is the one that controls the charging, the frequency of the inverter, the discharging, the current measurement, the voltage measurement. So this is the main board. It checks everything. It controls everything. And this one, it's a AC circuit and the SMPS. You see these yellow ones, they are switch mode power suppliers. So they convert high voltage to low voltage. So this one's a display card, obviously. And underneath there's a DC board. So if you look at these two terminals, they go not on this top board, but on the bottom board. So obviously when there's a short, it can't be that the short is on this board. The short is on the board underneath. So you've got another layer of a board underneath. So we have to remove that board, and then we can see how we fix this inverter. So now if I connect the battery there, there's nothing on the display. It's not showing anything. Connect 54 volts, nothing, because there's a short. So that voltage drops down to a very low voltage, which is not sufficient to run the SMPS. And that voltage won't even be able to run the display. So let's start. Now we're gonna strip this inverter, and then we can see how it goes. Let's take out the connection here. So the display, it's easy to see. There's only 3 wires there. So we'll have to remove this 3 wires. 1, 2, 3. Okay, we've got the display out. Now we have to take out this board. So obviously we're gonna have to remove these wires. Okay, we've got our first board out. Sorry, the second board. We already took out the control board. Okay, this is the board that has got a problem. So you remember I told you that there's another board. I took out the first one. So this one is the one that converts the DC battery voltage to 400 volts, the DC high voltage. So this is definitely the problem. I'm going to take it out further, and then we can remove this one, and then we can see where is the problem. Let's do that. So we have to take out this switch there. It was already loose. Okay, now we have to take out these terminals. So this one is our fuse, 255 amp, and this one is our current measurement sensor. This is the one that goes right onto the fuse. So it measures the DC current that's been drawn from the batteries. Okay, we have to take out this bus so that we can remove the screws there. So this is our problem. So this is our biggest problem. Let me take out the screws. Okay, I was taking out the screws that mounts these MOSFETs. So we don't want to lose those screws. Just want to make sure they are safe so that we can put them back. So these 2 points, these are your input. This is the DC input. So we are getting a short here. It means that the problem, it's obviously on this MOSFET and the IGBTs. So let's go on the table. I'm gonna go with you on the microscope and then we can see what is the problem. So now, yeah, I'm now on the table. We are going to check and see where is the problem. You can see these 3 points. These are your input DC bus, but you remember here we've got a fuse. See, the fuse stays there. So it means that this is more like one connection. So we're not gonna test here, we're gonna test here because it's one connection. So let's check with the multimeter and see what the resistance we're getting there. You can see we're getting 1.7 ohms. So that 1.7 ohm is very low, very low. So the 48 volts will be shorted by that resistance. So what we need to do is to check all the MOSFETs and see which ones are not right. Then we can put the new MOSFETs. Okay, let me move it here. I'm gonna turn the board upside down. Okay, I've got the board upside down. So by visual inspection, you can see that this MOSFET, there's a smoke there. You can see that MOSFET popped out. So that MOSFET could be the one, it's basically the one, but I'm sure there might be some other MOSFET that are not right. So let's take out that MOSFET and see. Let's take it out. We're gonna take it out properly. We just wanna test. So this MOSFET is not right. Okay, let's check what number is this. I'm gonna move to a higher resolution for microscope. Let's check and see this MOSFET. Okay, you can see the CK27N10. So the MOSFETs, they've got numbering, and that numbering, it means a lot. So you see this 27, it means that this is a 270 amp, and 10A, it's 100 volts. So we've got one MOSFET out. Let's take a look and see if the short is still there. Okay, so these are our 3 points. Let's check there. Right. Looks like it's open circuit now. Okay, we're gonna test all the MOSFETs to see if they're not shorted. See, that one is shorted. We have to change it. That one looks alright. That one looks alright. That one looks alright. That one looks alright. That one also. One looks okay. That is the shorted one, this one next to the one that's bent. One looks alright. Okay, let's check the other side. Okay, so we're gonna change these MOSFETs and see how it goes. I'm gonna look for another MOSFET just now, then we can replace it. Okay, let's take out the MOSFET. This one has got a short. This is buzzing. See, these ones are not buzzing. I'm just taking out the pins now. You can see the pin is out. This one is stubborn. Okay, this pin here, the middle one, is very tough. It's gonna be the last one to be removed. Let's clean here. I've turned the board upside down. The reason why those pins are not coming out is because of this copper mounting is reducing the heat. It's just, so it's actually draining all that heat. Let's just see if it's this side. we've got that pin. Okay, we've got the holes open, so I'm going to get new MOSFETs and then we can connect them. Okay, we're now going to change these MOSFETs, these two MOSFETs. I've got the replacement MOSFET. You can see there, these are the MOSFET that we're going to use. These are brand new MOSFETs. Just have to bend them. I'm using two soldering iron so that we can have more heat, so that the solder will flow smoothly. Because these boards are very thick. If you use one, you can have one soldering, you can have a dry joint. So let's clean the board. Okay, we're using this spray. You see, you can clean this using this spray. It can clean lots of things. You can see the PC board there. Okay, I've got those two MOSFETs replaced. Let's check just to make sure that the other ones are okay. Start there. 300 ohm. Just to be really short. 297, 300 is okay. 10 kilo ohm. This one I doubt. Not reading like those other two. 300 ohms. 300 kilo ohm, 300 kilo ohm. Even this one is not right. We've just changed it, but it could be that the components, the driving circuit is not right. 300 ohm, kilo ohm, 320 kilo ohm. 294 kilo ohm, so it's also 300. So this one, 1 kilo ohm is doubting. 0.7, 0.7. So let's take out these other ones and see. This one we've already changed it, but we have to check and see why it's giving that low resistance. Okay, let's check out this one. It's not easy to take out this MOSFET because the solder is too strong, also that they can hold a lot of current. Let's try and open the holes. Let's put some flux. Okay, I've got those other ones sucked out. Let's check the resistance. Okay, you can see this one we're now getting good value. This one also getting right. This one is getting right, and this one is picking up. So there were lots of MOSFETs that were shorted here. Okay, but once we change this MOSFET, we have to change to repair the driver circuit as well on all the MOSFETs that were replaced. Okay, this is the driver circuit. You see there you've got some optocouplers. I'm gonna take it to the microscope. You can see clear. Okay, I've got the board on the microscope. Let's fix myself here. Okay, I've got the board on the microscope. This is the 3 pins of the MOSFET that we've changed. Let me clean it. This is the other side of the board. Okay, so this is the one that we've changed. So the reason why I'm talking about the driver circuit is that once the MOSFET short circuit, there's high chances that the driver circuit is also damaged. So what I'll do, I'm gonna check and see if the driver circuit is okay, and then we can fix if it's not okay. Let me okay, so this is our driver circuit. So one of the things, we have to check the resistance of this resistor. This is the driver circuit of one of the MOSFET that we changed. You can see there. So this is the gate. Let's check the resistance. 10R0 is 10 ohms. Let's check. You can see we're getting 0.9 mega ohm, so this resistor is not right. Let's check with the ones that we haven't changed. See this one. This one next to it. Okay, 10R0. You can see this one is reading another value. Okay, you can see there is 10 ohms. So this one is reading okay. So it means that the driver circuit is not right. Let's check again. You can see 0.9. So this resistor is not right. And also, once this resistor fails, this optocoupler there, it needs to be changed. We can't change the resistor and leave the optocoupler because it's connected. You can see this resistor is going straight to the optocoupler. If the resistor blows, the optocoupler is damaged. So we have to change that. Okay, let's go to the next one, this one. This is the next one that we've changed. I'm sorry, this one. Let's see. So it's this one, the other MOSFET that we've changed. So we're getting 18 kilo ohm. So it's also not right. This is a 10 ohm resistor. So we also have to change the driver and the resistor. So it's always better to just change all the MOSFETs that were damaged. We're gonna change the driver and the resistors. So in that way we will be sure that everything is okay. That's what we're gonna do now. Okay, I'm just going to change one driver circuit. I'm gonna do the rest, but for the sake of this video, because it's gonna be very long, I'm just gonna change one, then we can see how it's been changed. There is the driver ICs. Let me show you. You can see these are the new ones. The driver IC optocouplers. Let's take out this resistor. Just use a water station. Get the resistor out. Let's take out the optocoupler. Okay, there you go. There's the new optocouplers. There is the resistor rail. These are the 10 ohm resistors. See, these are the new ones. Just gonna take out one there. Hey, this optocoupler is jumping up. It's going to the other side. Let me get another one. Just gonna use a soldering iron to be sure that the contact is clean. Okay, that's good. So to be 100% sure, just put the tweezer and push these pins so they're not moving, so everything is in. So I'm gonna do the same thing on the other ones that we've changed, and then I'm sure it's gonna be okay. And then we can take the board to the machine, then we can run it. Okay, but before we can connect the board back to the inverter, we have to put back the thermal paste. Oh, this is very important for heat transfer. So on these other MOSFET, there's no thermal paste. These are low voltage MOSFET. They are thermal pads. You see these pads? These are the ones that we use if there's a need. So these are the pads that we use. So if one of the MOSFET, you can see these ones, they peel the pad a little bit, so it's no longer safe. So we're going to just put another pad there, then the inverter will be safe. Okay, I'm gonna go back to the table now and install it back. Okay, we've got our first board in. So now we have to connect the DC bus and the fuse and the current sensor. You remember this current sensor? We have to put it back, and let's start with this one. Okay, let's not forget our fuse. It has to come back. These are our 2 input bus bars. Okay, I'm just opening space for the second board so that these wires don't disturb us. Okay, before we can install the other board, we have to put this casing in. Okay. Now it's time for us to there's 2 more screws here. Okay, we can install our second board now. Okay, there's one screw that jumped. It was around here. Got it there. Okay, we're just gonna test the inverter first. We'll connect the PV switch after. Just gonna test and see if everything is okay. Okay, we are done with the repair of this inverter. We're just doing the final test. We have connected the solar panels, we've connected the grid, we've connected the output. You can see there's already an output. We've got the light connected there. So we've got an output. You can see the screen there. It's showing that the inverter is charging from the panels and the grid. So you see these arrows are pointing on the inverter. So you can see there's an output that goes to the house. So the inverter is working 100%. Okay, let's check if the inverter will work without the grid and the PV. Let's check the grid first. You can see we have 228 on the grid. And then on the solar panels, I'm gonna switch them off, and then we will leave the inverter to run alone with the battery. Okay, we've got 180, 200 volts for the PV. You can see there, PV 189, it's the same voltage that we're getting on the terminals on PV1. Okay, let's now check the inverter if it can run without those. Let me switch on the PV. See, the light is still on. Okay, we're still getting an output. Let's check on the load. We've got 228. Let's switch off the grid. You can see the panels are now off. They are now off. Even on the display, we've got 0 volts there. Let's take out the grid. We are now off grid. You can see there's a red mark to show that there's no incoming power. The light is still on, so we are running the inverter without the ESCOM line or the grid and the PVs. So the inverter is running with the battery alone, and it's running okay. So we are done with the repair of this inverter. It was a long job because we had to fix this inverter. It took us 2 days to get this inverter working because it's a very, very big job. This one you have to take your time and fix it. I hope you will like this video. subscribe if you haven't, and hope to see you back on the next video. Okay, thank you.